rational expressions. Okay, we've got two scenarios. So the first one we're going to look at is if the problem has monomials only. Okay, so single terms. There's no addition and subtraction anywhere. So like 9 and 10. Those are rational expressions with monomials. Yes, I know we have multiple variables and we have coefficients, but there's no addition or subtraction, so those are considered monomials. So what we do with that? It's just like multiplying fractions way back in elementary school. You multiply the numerators, you multiply the denominators, and you simplify. So that's what we're going to do. We're going to multiply together and then simplify, and we're going to have to use some of our exponent rules. So if we multiply straight across the top there, we've got 6 times 10 gives us 60. X squared times x cubed. What do we do with those exponents when we're multiplying? We add them together, so that's x to the 5th. Okay, y cubed times y to the 4th. We add them together, that gives us y to the 7th. In the denominator, 2 times 18 is 36. X squared, we don't have another x squared, so we just bring it on down. Y squared times y squared is y to the 4th. Thank you very much. Okay. All right. So now we simplify. We simplify coefficients if possible. So 60 over 36, what's the biggest number that divides evenly into both of those? 12. Okay, 60 divided by 12 is 5. 36 divided by 12 is 3. Now, what do we do when we are dividing exponents? Or divide? We subtract. Okay, multiply, you add, divide, you subtract. So the way that I always do it is I always do the biggest number minus the smallest number, so 5 minus 2, and you put it where the bigger number was. So 5 minus 2 is 3. It was bigger in the top, so x cubed goes in the numerator. Same thing with y to the 7th over y to the 4th. 7 minus 4 is 3. It was bigger in the numerator, so that's where it goes. Okay, and that is fully simplified. Okay, we have multiplied it out and we have simplified. So those are equivalent to each other. Okay, number 10, same thing. Okay, multiply straight across the top. 4 times 5 is 20. A squared times a cubed is a to the 5th. B squared times b to the 6th is b to the 8th. In the denominator, 15 times 12 is, I think, 180, if I remember correctly from first period. And a times a to the 4th is a to the 5th. Be careful with that one. When there's not an exponent, it's understood to be 1. And b cubed times b to the 7th is b to the 10th. So again, we simplify 20 over 180. That leaves us with 9 in the denominator, because 20 divides into 180 evenly. A to the 5th over a to the 5th, those kind of cancel with each other. Okay, or you can look at it as 5 minus 5 is 0. Anything to the 0 power is 1. That's another way to look at it. B to the 8th over b to the 10th. 10 minus 8 is 2. It was bigger in the denominator, so it goes in the denominator. So I don't have anything left in my numerator. Does the 9b squared just go up to the numerator? No. We got to put a 1 there. Okay. We got to put a 1 there. I don't mean to sound sarcastic, but I just did it because people do that. There's nothing in the numerator, so the numerator just disappears. Okay, you have to put a 1 in its place. Okay, so next scenario, when we have binomials and trinomials, or if we have a mixture of binomials and trinomials with monomials, then the same thing applies. We factor everything that we possibly can first, and then we're going to simplify. Okay, we factor everything we possibly can first, and then we simplify. So how do we factor that first numerator there? We take out a 4x, right? Both terms have a 4, both terms have an x. When we take that out, what are we left with? X minus 1. Okay, don't forget that minus 1 there. Now, since this really, when you multiply and you multiply the numerators, it just becomes one big fraction, then I'm just going to keep going and factor my second numerator here. Okay, so that is, it doesn't have a GCF, so we jump straight to a binomial times a binomial. X times x is x squared. 3 times 2 is 6. Positive 3 minus 2 gives us positive 1. So my numerator is fully factored. Now my denominator. What do we need to do in the denominator there? Pull out a 2 first. Now, just to save myself some space here, I'm going to do that right below the denominator, and then I'm going to finish factoring it down here. So we get x plus 3 times x minus 1. Now, you can do it wherever you want to. I'm just saving myself some writing and some space. All right. And then the second one, we pull out a 4x. So we're left with x plus 2. Notice that that is times 4x because we're multiplying across. Okay, I've seen some people want to stick a plus or something in there, but that's not what happens. Okay. So let's see here. Now we're in the boat of what we did yesterday. We've got a numerator, we've got a denominator. It's in factored form. We just need to cancel anything that shows up in both. So what can we cancel? Okay, x minus 1 and x plus 3, 4x. Okay, we can cancel out the 4x there. So what are we left with? We've got an x minus 2 in the numerator. If you want to leave the parentheses around it, that is fine. You don't really have to in this case because it's the only thing that's left in the numerator. Okay, and in the denominator, don't lose that GCF of a 2 there. And then we've got an x plus 2 on the end. Alrighty, let's look at number 12. Let's look at number 12. 10v minus 5v squared. What do we not like about that? It's not in standard form, right? We don't like that. So right above it, I'm just going to flip the order real quick. I'm going to mark it out. Everything else looks good. So now I can proceed with factoring. So what should we take out of that first numerator? Negative 5v. Very good. Negative 5v. So we're left with a v minus 2. Be very careful with that. Positive 10 divided by negative 5 is negative 2. All right. Second numerator, no GCF. So we split it into two binomials here. V times v is v squared. 9 times 1 is 9. Negative 9 plus 1 is negative 8. All right, denominator. First denominator, no GCF. So two sets of parentheses. V times v is v squared. They're both minuses. 9 and 2. 9 times 2 is 18. Negative 9 plus negative 2 is negative 11. That second denominator is a monomial, so we just leave it. Okay, we don't do anything to it. If you really wanted to, you could, like, since we got a 5v in the numerator, you could make that 3 times 5v, but you really don't have to, okay? I just wanted to point that out. All right, so let's see here. What can we cancel? B minus 2, B minus 9. What else? The v. Okay, we can cancel just the v, and then we can simplify 5 over 15 to leave us with 3 in the denominator. Okay, so don't lose that minus, though. That was in the very front. We've got negative. This time I do need the parentheses around my v plus 1 because there's something else in the numerator. There's a negative up there. And the only thing we have left in the denominator is a 3. Now, you may see it like this. You may see them distribute the negative. Okay, so negative v minus 1 over 3. But either one, I'm good with either answer. Okay, you can leave it in factored form. Just make sure you've got parentheses there. Or you can distribute out the negative, whichever one works for you. As long as you recognize that those are the same thing.